Hey guys, wanted to talk a little bit about math today and the math that we use in physics and how to go about doing some things that you probably know but might be a little bit rusty on. You do need a calculator. That calculator better have a sine, cosine, tangent button, and it needs to have a square root functionality. Other than that, I don't really care. If you have a $100 or $80, whatever they are now, graphing calculator, that's fine, bring it. If you don't, go down to the big box store and get yourself a scientific calculator. It's got to have a sine, cosine, tangent. It's got to have a square root, but you should be able to get one for around 10 bucks, 8 to 12, 8.15, something like that. These are fine. It's better than what I had when I went to school. I do like the ones that have two-line display there so that you can write out the whole expression, hit enter, and see the answer there. It evaluates the whole thing all at once. All right, it's not strictly necessary, but it'll save you a whole lot of trouble. All right, calculators. Here's some tricks on calculators I want you to know about. The first thing here, we're talking about set your calculator to degrees. Real quick here, we're going to need to start working with trig functions. I'm going to show you a couple in just a minute here, but let me show you what I mean. When we go to the calculator and I come in here and I say show me the sine of 27 degrees, I get that number right there. You don't need to know what that means right now, but watch this. If I hit the mode button and go down, down, enter that, and hit sine 27 degrees, I get a totally different number. One of those is right if I'm measuring in radians, in degrees, and the other is right if I'm measuring in radians. So you need to know which one you're working in, and then make sure your calculator knows which one you're working in. Everything in my class you want to do in degrees. So you can come here, hit the mode button, go down, down, right, get the blinky thing on degrees, hit enter, and you're good. And just leave it there all semester unless you've got a trig class. The right answer on that would be sine 27 is 0.45 something. Okay, so that's the easiest way to mess yourself up. Here are a couple other easy ways to do this thing. If I've got a calculation like this one's pretty simple, but you know that 12 divided by 2 times 3, that 2 times 3 is a 6, and 12 divided by 6 is 2. So 2 is the correct answer here. But check this out, there's 3 different ways that they put this into the calculator. Only 2 of them are right. If I do it this way, I get the wrong number. The reason is your calculator thinks in order of operations. So remember what Aunt Sally said, please excuse my dear Aunt Sally. It's going to do the parentheses first. It's going to try to do exponents. It does multiplication and division on the third priority rung, and addition subtraction comes in last. So when it sees and anything it finds on the same rung, it does left to right. So when you say 12 divided by 2 times 3, it says that division is just as important as the multiplication. So I'm going to do the 12 divided by 3. That would give you, 12 divided by 2 would give you a 6. And 6 times 3 is 18. Wrong answer. Okay? Don't do that. You get 2 choices. Option A is to say 12 divided by parenthesis. You can put one at the end if you want. That holds that 2 times 3 together, gives you the 6, and then 12 divided by 6 would be 2. That works fine. The other thing you can do is to remember that this fraction bar right here really means divide by. So I've got 12 divided by 2, and I've also got divided by 3. So you could say 12 divided by 2, that'd give you a 6. 6 divided by 3 would be 2. So either one of those works. Just kind of be careful and think about what the calculator thinks you're saying to it. It does exactly what you actually say to it, so watch out. Here's another example that will get you into trouble. If you do 12 plus 6 over 6, you really should say 12 plus 6 first, get that 18. Do the whole numerator before you start dividing right there. There are ways you could write the other thing, but look at this over here on the calculator. If you go 12 plus 6 divided by 6, what's it going to do first, addition or multiplication? It does the multiplication first, or this division rather, sorry. 6 divided by 6 is 1. 12 plus 1 is 13. Wrong answer. Okay, no good. So there again, those parentheses will hold the numerator together. 12 plus 6 is 18. 18 divided by 6 is 3. That's the right answer. Just be kind of mindful of what's going on into your calculator. Here's some unit conversion stuff. Lots of units, lots of measurements. All of them have units. So the first thing you need to know is the conversion factor. And it's given right here on a test or something. That would be given. I don't expect you to memorize these, but you do need to know how to use them. If my conversion factor tells me that 3 feet is the same thing as 1 yard, then I need to take half of that conversion factor, put it on the top or the bottom, and the other half goes in the other place. How do you decide which one goes where? I need to look and say this is feet. The feet are on top. I can make that look like a fraction if I want. And if the feet are on top, then I need to put the other feet on the bottom such that the feet on top cancel the feet on the bottom. Set it up opposite, and you're good to go. That leaves a place for 1 yard up here. And now that I've used the units to tell me how to set this thing up, I see that there's a 12, there's a 1, there's a 1, there's a 3. Multiplying by 1 doesn't do anything. Dividing by 1 doesn't do anything. So I'm going to leave the 1's out. And see how that 3 is on the bottom? That's a divided by 3. Right there. 12 divided by 3 would be 4 yards. That's the right answer for that one. If I do this second one here, I'm trying to go the other direction. Yards into feet. So I got yards on top. I need to put the yards on the bottom. And then yards on top will cancel the yards on the bottom. I put the 3 feet on top. And since the 3 is on top, now I'm looking at a multiplication problem. 15 times 3 would be 45. Sometimes you multiply, sometimes you divide. Nobody wants to memorize all the different possibilities. Just let the units do the work. Watch the units and set it up so that the units you don't want cancel out and the units you do want end up where you want them. Here's one that has 2 steps to it. In this case, we're trying to turn miles into meters, hours into seconds. So you'd have to know or be given or look up those conversion factors. I happen to know them, so I'm going to put them here. 1 mile is 1608 meters. With that one, I've got miles on top. So I'll put the miles on the bottom. Miles cancel out, and that'd be 1,608 meters on top. Okay? I also know that 1 hour is 3,600 seconds. 60 seconds times 60 minutes would be 3,600. And since the hours are on the bottom, then I need my other hour on the top. The hour on the top cancels the hour on the bottom. I put the 3,600 seconds down here, and we'll calculate this thing up in just a second here. I need to do 62 times 1,608 divided by 3,600. And that's 27.69333. Turns out we don't really want all of that number. 27.693333 is forever like that. Looks kind of silly. Okay, here's the rule I'd like you to use. Go to the numbers that you started with. In that number there was 1, 2 digits. We would say this has 2 significant digits. Okay? I'm not counting the ones over here or the ones down here because those were given. Those were not part of my measurement. We're interested in how much accuracy our measurement had. And we only had one number in our measurement. It had 2 significant digits. So my answer needs to have 2 significant digits. Here's the first digit that I'm interested in, and here's the second one. Pretty much this number's trapped between 27 and 28. And we're trying to figure out which one it's closer to. So if I look at the third digit, if it's 5 or greater, we can round up. 27.69 is a little bit closer to 28 than it is to 27. So properly, the answer here would be 28 meters per second. Now, I can hang with 27.7 meters per second. That would be okay. All right. That's one more significant digit than we really ought to have. In physics, we're not really that persnickety about it. The chemists, they're pretty excited about this idea. If you take a chemistry class, they're going to want you to have exactly the right significant digits. We want to understand how everything works. We're not interested in bickering over how many digits the answer has. We want to know, how do I get the answer? So it's a little bit different point of view, and that's okay. Here, wanted to do a couple algebra problems. This first one's pretty easy. Looks pretty familiar, right? The game is to get x by itself. And I see that I've got that 3 there I'm going to have to do something with. I've got a plus 4 I don't like. I want to move both of those. Well, I can do anything I like as long as I do it to both sides. So I see that plus 4, and I say I want to get rid of plus 4, so I'm going to do the opposite. Minus 4. Plus 4 minus 4 is 0. It's gone, right? I'm left with 3x. But I did something to the left side to keep it balanced. I got to do the same thing to the right-hand side. 13 minus 4 would be 9. Okay, we're one step closer to having x by itself. Now I need to get rid of the 3. Well, the 3 and the x are multiplied. So the opposite of multiplication would be to divide. And 3 divided by 3, the 3's cancel, leaves me x by itself like I wanted. What I did to the left, I got to do to the right. 9 divided by 3 would be 3. Okay? And hopefully you're 100% comfortable with that problem right there. If not, come around, we'll work some more of these or something. But let me show you the second one, because it's the same problem. Just for some reason, sometimes people get tangled up if there aren't any numbers in it. If I want to get this x by itself, I got to get rid of the a, and I got to get rid of that plus b. So just like we did in the last problem, if I subtract b from both sides, the b's would cancel on the left. I'd have ax equals c minus b, and then I could divide by a, and a divided by a cancels, so I'd have x. What I did on the left, I got to do on the right, and I'd get something like that. Okay? It's nice to be able to work generically without a specific number in there. If this is always true right here, then this is always true right there. And we're not relying on certain values to go in there. It's always true. We like things that are always true. We want to know how things always work, okay, in the general sense. Over here is a little bit more convoluted problem. We'll work through this one and see what we want to do, but it's the same process. If I want to get that x by itself, then I need to move the c, move the minus 4, and move that divided by 6t. In this case, I would multiply both sides by 6t. And the reason I would do that is because when I multiply the left-hand side by 6t, the 6t on top cancels the 6t on the bottom. Okay? And I'd have cx squared minus 4 equals, now I got to do what I did to that other one. So I'm going to slip a 6t in right there. And you can see there's two things in there. I could leave it like it is, or I could distribute the 6t to those two sides. You kind of have to decide which one will make it simpler and cleaner and look better. I think I'm going to go ahead and distribute. I'll take the 6t times the first term and then multiply 6t times 8t like that. Let's see what that would look like. 6t times 4 pi ra over 6 plus 6t times 8t. That's the distribution there. Let's clean up a little bit. The 6 on top cancels the 6 on the bottom, and that t can go anywhere in there. I usually like to get the constants out front and put the variable last, but that's kind of up to you. 6t times 8t would be 48t squared. So that cleaned up pretty well. Over here I've got cx squared minus 4. This is starting to look like that other problem we did. I'm going to add 4 to both sides. The 4's will cancel. I'd have cx squared equals, I tell you what we do, why don't we rearrange the order here. I'm going to pull that t squared up into first place. I'll have 4 pi rat, and then that plus 4 is bringing up the end of all this. I want to get rid of the c, so we'll divide both sides by c. The c cancels on the left, and it'll just sit underneath right there. I want to get rid of the squared. I don't want x squared, I want x. And the opposite of squared would be square root. So I'm going to take the square root of the left-hand side, which means I got to take the square root of the right-hand side. Notice that's the whole thing, top and bottom, everywhere. So the square root of x squared would be x, and then nothing really changes over here. I don't see anything that I can pull out or factor or do anything too fancy, so I'm going to just copy all of that right there, and that's about as clean as I can make that. All right. But algebra is pretty important. We use a lot of it. You will be very good at algebra by the end of this class, and hopefully you're pretty good at it now. So a little reminder there. I want to talk a little bit about geometry. Here are some real quick shapes, triangles, rectangles, circles that we encounter in everyday life. So if you think about a triangle, there's kind of two numbers that we're interested in. One is the area. That's the space inside, and the other is the perimeter, the distance around the outside of it. So if I wanted to know the area of this thing, I'm going to name the sides here. Why don't we call this A and B and C, something like that. Okay. The area is 1/2 the base times the height, so I'm going to write 1/2 AB, something like that. Okay. If you're using B and H, then it'd be 1/2 BH, but whatever you name the sides of your triangle determines what variables get used in that formula. If I walk all the way around this thing, I'd have to walk A, and then walk B, and then walk C, so the perimeter, the distance around, is just going to be A plus B plus C, like that. No big deal. Given a rectangle, if I call the long side L, length, and the short side W for width, those are supposed to be straight sides, then the area, the space inside here, is given by length times width, and the perimeter, I'd have to walk L plus W plus L plus W. I'd have 2 L's and 2 W's, so that would be the easiest way to write that, like so. Lastly, if I had a circle, I could talk about the space inside the circle, the area of the circle. Generally, when we talk about circles, we're given the radius, which starts at the center of the circle and goes to the edge. Sometimes we have the diameter, which would go all the way across the circle through the center of the circle, so it'd be twice the radius. But I'm going to work with R here. If they give you the diameter, just cut it in half. Just take half of it, and that'll be the radius. Okay, but the area of the circle is always given by pi r squared. The perimeter, the distance around the circle, which we now call the circumference, because it's special, it's a circle, is 2 pi r. So just kind of some reminders about geometry there. And the only other thing I really wanted to talk about was trigonometry real quick. It may well be that you've never seen trigonometry, in which case let's demystify that real quick. If you have, then that's fine, but either way will work. This is a right triangle. The only trigonometry I need you to know about is right triangle trigonometry. It should have a right angle, a 90-degree angle in one corner. So I'm going to write right triangle. I already got the trigonometry right there. And right triangle trigonometry has 3 trig functions that are called the sine, abbreviated down to sin theta, the cosine, cos theta, and the tangent of theta. And that's what those 3 buttons on your calculator do. The sin, the cos, and the tan are the sine, the cosine, and the tangent of theta. Now theta is an angle. This is the Greek letter. We've kind of run out of English letters to use, so we slip over here to the Greek for anything about rotation, about circular motion, anything like that. Theta I'm going to call the angle of interest. They either give me that angle or they're asking me to go find it. In interest. There we go, I think. So they might say a hill goes up at a 25-degree angle. And I'd be interested in that 25 because it's one of the numbers that they gave me in the problem. Okay? But here's what I got to do first. I got to say, well, if that's theta, then straight across from theta is the side that we're going to call the opposite and abbreviate OPP. The side directly across from the right angle is going to be the hypotenuse, which gets abbreviated HYP. And the other side, the side right next to theta or adjacent to theta, is the adjacent, ADJ. And as soon as you've labeled those sides, then you can define the trig functions, and they're always the same. It's super easy here, okay? But please notice if right now this is theta, so that's my opposite. If for some reason they had given me this angle, this would no longer be the opposite. It would be right next to theta. It would be the adjacent, and the opposite would be opposite straight across this side, which before we called the adjacent. So you need to know which angle is your angle of interest and then name the sides based on that. Straight across, right next to it, and the hypotenuse. Okay? Anyway, the sine is always the opposite over the hypotenuse. In this triangle that we have, the opposite is the length of this side, and the hypotenuse is the length of this side. Okay? You're going to divide opposite by hypotenuse, and that ties together with this angle theta. This number, and that number have to work together. What would happen if in that triangle all of a sudden the opposite got a whole lot bigger? What would happen if the height got up here this big? If my opposite grows, now I need a longer hypotenuse and the angle changes. Right? You see how those three are linked together? The cosine is always the adjacent over the hypotenuse, and tangent would be opposite over adjacent. Okay? I'm going to put a box around that. That's pretty important stuff. Probably want to put that on your index card or something like that. But I'm going to erase this stuff we did here. Me blathering on about it. Okay? And going back to what we had here, let's do just a real quick problem. A 20-meter cable is tied to the top of a pole. And makes a 27-degree angle with the ground. Okay, so in something like that, here's theta. I see that 27-degree angle. That's my angle. So I could go ahead and put a 27 right there. And I see this 20-meter cable. I got a pole that's going upwards, and my hypotenuse is 20 like that. Maybe they come along and ask me, find the height of the pole, find the opposite. Okay, so I'll put a little question mark right there. And what you got to do is read the problem, find the numbers, figure out what side those correspond. There's the three numbers that we're interested in: the theta, the hypotenuse, and the opposite. And I come over here and I look for a trig function that's got theta and hypotenuse and opposite. They all have theta, so don't worry about that one. Opposite and hypotenuse is sine. So I need to grab the sine. I need to grab the sine is equal to the opposite over the hypotenuse. I am looking for the opposite, this guy. That divided by hypotenuse is in my way, so I need to get rid of that. The opposite would be to multiply by the hypotenuse. The hypotenuse on the top cancels the hypotenuse on the bottom. Whatever I do to one side, I do to the other. The hypotenuse was 20 meters. Here's the sine. Theta is 27 degrees. And that should be my opposite. I'm going to call it h for the height of the pole here. And if I do 20 times sine of 27, then I'll have that answer. So here we go. 20 times sine 27. That's 9.0798. 9.1 look okay? Thinking about significant digits, 2 digits, right? So I'm going to write down 9.1 as my answer here. And of course the unit would be meters. Okay, so there's no magic to trig. You're just using the ratio of the sides and how that relates to the angle that's across there. We'll do more of those if you like. Okay, but that is some of the math that we need. Of course, if you're in 221, we're doing some calculus as well, and we'll talk about that at another time. But thank you very much and have a good day.